Hello, high school astronomy students. Mr. Z here for another lesson, this time on how to tell time with the moon. First off, let's start as we've started every other time, and that is introducing you to the evening sky. So you can see right here is April 29th. That is Wednesday of the week. We have a 9 o'clock time. So if you take a look at the sky, hopefully you've been looking up there and seeing our familiar Leo, Orion, and Ursa Major all in the sky. Those would be the iconic constellations in the sky. We also still have around with us here the planet Venus. Yes, it is that big bright, it is that very bright dot in the western sky. The other thing we have in our sky tonight is the moon. Now the moon is going to be important to us because that's how that's what we're learning today, is how to tell time with the moon. So let us go ahead and get into the lesson, and then maybe even tonight on Wednesday night or even the following nights you can get out there and use what you're about to learn. Last time we were here together, we were taking a look at the sun, and we learned that time is basically the position of the sun. That's what time is. So when the sun is 1 hour past the meridian line, that's 1 p.m., 2 p.m., 3 p.m., each hour that the sun is past the meridian. Then we learn that a.m. is anti-meridian. So when the sun is over in this area here, that means the sun is 8 hours past anti-meridian, which is where midnight would be. So we learned that the sun is really what time is, the position of the sun. So why do we need the moon? Well, what if the sun is down? What if the sun is set but the moon's up? The point here is that you can use the moon to tell where the sun is located. Let me show you this. We're going to start actually. Let's start first at this. There we go. So notice here, now this is a moon that you wouldn't technically see in the sky because we're going to start at new moon, but we're going to go over the phases here in a second. But I just wanted to sort of start this off here. So we have the sun at noon, and there's the new moon. All right, so I wanted you to realize that the new moon is up during the day. It's very close to wherever the sun is as well. Knowing this very simple, what seems a very simple concept is quite important, and the extension from it. So let us take a little time and review why new moons appear, or for that matter, all of the phases appear. All right, so let us go to this little quick PowerPoint that I have set up for you. All right, so as you can see, the sun is here on the right. There's the moon, and the moon is half lit up. You can see it's lit up towards the half that's facing the sun. Hopefully that makes sense to you. The moon does not produce its own light. It does require the sun to light up this half. So this half is the darker half, we'll call the nighttime side of the moon. The Earth does the same. It has its day half and its night half as the moon. Now, from our point of view, so that's our eyeball looking up at the moon, this is the portion we see. Now, we don't see beyond this line here because everything back here is on the other side of the moon. The moon itself is blocking it. So when you think about it, if we're seeing it from this point of view, all we see is the nighttime part of the moon. And that's what gives us new moon. Technically, a moon we never see. We can't see it. It's not lit up. And even worse, the sun is located around it. All right, so the sun's too bright, the moon's not lit up, or at least the part of the moon that's facing us is not lit up, so we don't see the new moon. But it's important to understand why we don't see the new moon. Let's go a couple days later. The moon orbits the Earth. So as the moon orbits the Earth, you can see the same half of the moon is still lit up, the half facing the sun. But we now have a different angle to that half-lit moon. And because of that, you can see this little portion right there is now what we can see. Most of it's still dark. Most of it's still nighttime, but you can see a little portion of the daytime there. Well, that's perfect. That's what creates our crescent moon. This little crescent that you see on the moon is just that little sliver of the half of the moon that we can see. That's what gives us our crescent. As the moon continues to orbit, eventually it gets to its what we call the quarter phase. This is when we see, technically 1/4 of the moon. So you notice that you already can only ever see one half of the moon, but we're only seeing one half of the half-lit side. So that means a quarter moon. So that's why we call this the quarter moon, because one, it's a quarter of the way around its orbit, but more so is you're only seeing 1/4 of the moon. If I show it like this might make more sense. The red is what you can't see. This half can't be seen because, well, I should say this quadrant can't be seen because it's dark. This half can't be seen because it's behind the moon. So that leaves you only this quarter of the moon to actually see. And that's why we call it a quarter moon. Then we go into that phase, that weird looking phase, that it's beyond quarter but not quite full. So from our point of view here from the Earth, you can see that we see most of the lit half of the moon, but we have just a small portion of the nighttime half. We call this the gibbous moon. This is when it looks like almost a circle but not quite, and so we call that a gibbous moon. And finally, of course, when the moon gets to the other side of the Earth from when it started, now the entire lit half of the moon is facing the Earth, and so we as inhabitants of the Earth look up and see that entire lit half. We call that the full moon. Never been a fan of calling it a full moon. I would be happier if we always called this the half moon. That makes more sense to me. Since we called this the quarter moon up here, this should then be called the half moon here. But whatever, it's the way we work here. I guess it's the way the world likes to call it. They call it the full moon. Actually, you're going to learn later, I actually don't like any of these titles. I would love to be calling this the 0-hour moon, the 3-hour moon, the 6-hour moon, the 9-hour moon, and the 12-hour moon. But you'll understand what that means in a little bit. So you can see that these are the 5 phases of the moon here. So we have the new moon, the one you can't see because the far side is lit up. Then you start seeing a little bit of the moon, a little bit more, a little bit more, and a little bit more of the daytime half of the moon. Then, of course, you have, as it starts to go away, as it completes its orbit, it's going to start getting smaller. So you get another gibbous, another quarter, another crescent, and new. Now, so when it starts to grow, we call that waxing. So when we start from the new and go around, you start getting bigger and bigger and bigger, we call that waxing. Once you are fully grown, you then start to wane. So we call the shrinking phases here from full all the way down to new, we call those waning phases. All right, so that's just a quick review of our phases, which is definitely going to be important here because you're going to have to remember our phases in order to really get this lesson. All right, so let me just bring up this. That's what I needed. All right, so we go back to the new moon here. All right, now why is the moon's position important to us, or why was the moon phases important to us? Well, let me show it to you from above. This is when it will start making sense why we had to do what we did. So there's the Earth in the middle, there's the moon, and there's the sun on the outside. Now I'm just going to advance this through a month or through one lunar orbit. And you can see right now, because Earth, moon, and sun are all lined up this direction, we see nothing lit of the moon, and that's our new moon. All right, but as I advance a few days, you can see there's our crescent. We're starting to see just a little bit of the crescent moon. And another thing I want to point out, notice how the lit side is pointed towards the sun. That's going to be important a little bit later. I go a little further, there's our quarter moon right there. Here's our gibbous moon, you can see not quite full. And then of course full moon over to there. Okay, so let me return back to the new moon. And now let me just take it to the quarter phase. Now let's remember why we call it a quarter. First off, you're only seeing a quarter of the moon because half the moon is lit and you're seeing half of the half-lit side. But more importantly, I want you to think of the angle. Okay, this is a 90-degree angle here. The moon is 90 degrees across its orbit. Okay, if it did another 90, it'd be 180, 270, 360, 360 degrees in an orbit. So this is completed 90 degrees of its orbit. Well, let's go back to halfway. Okay, if I take it back a few days, here's halfway through that orbit. So that's 45 degrees around its orbit. And what phase is this phase? Of course, that's the crescent phase. So why do we care about these degree measurements? Well, you already know this from both the day, from measuring months and days, and also measuring the time of day using the sun. You know that 15 degrees equals 1 hour. Well, that's coming back another time. That's very important here, because we can now think about this as, well, if 15 degrees is 1 hour, then this is 3 of those, right? Because 15 goes into 45 3 times. So we can think of this crescent moon as a 3-hour moon. All right, so if we move forward that couple days and go back to the quarter moon, then how many hours is a quarter moon? Well, 90 divided by 15 is a 6-hour moon. We go a couple more days. Now we have a gibbous phase. The gibbous is a 9-hour moon. And finally, the full moon is the 12-hour moon. So if you think of this more of a clock face being 24 hours all the way around, well then 12 of that's halfway, and that's why you get the 12-hour moon. All right. So we've just converted the degree measurement that they are around their orbit and just converted it into hours. That's all we've done. So when I summarize this, you see it this. The new moon was at 0 degrees and it's 0 hour. It's with the sun. There is no degree difference between the sun and the moon because the new moon is located at the beginning. Actually, let me go ahead and back up this to the new moon. There you go. So there's the new moon. So you can see that the new moon is 0 degrees and 0 hours away from the sun. All right. As I advance a couple of days, now the crescent moon is 45 degrees or 3 hours from the sun. So crescents are 45 degrees, 3 hours from the sun. And so this list is just a nice summary of our degrees and hour conversions. Once you understand that that is what's going on as the moon orbits the sun, that's what's going on in space, I hope you're starting to realize how this translates to the sky. Okay, new moon's in the sun, crescent's 3 hours, quarter's 6, gibbous 9, full is 12. Let's go back to the sky. All right, so here's our sky. Here comes our time measurements, our time positions. Let's remember these are the position. Even though if I move forward, for example, if I move forward an hour, yes, the sun's in the 1 p.m. position, but that doesn't necessarily mean it's that time. All right, but let's do. All right, let us do the waxing crescent moon. Okay, so waxing crescent. What have we learned about it? Well, we know that the waxing crescent moon, or just a crescent moon in general, is 45 degrees or 3 hours away from the sun. So I want you to notice. Now here, we wouldn't need to use the moon to tell the time because the sun's in the sky. So we could just tell the time with the sun. But I'm using this screen for a second, or this time of day, just to get to teach you the concept of this. Notice how many hours separate this crescent moon with the sun. The crescent moon's at the 9 a.m. position. That's 1, 2, 3 hours until it gets to the sun. Well, crescent moon is 3 hours from the sun. That's not a coincidence. To be a crescent moon, the moon had to orbit 45 degrees around its orbit, which equates to 3 hours of time in the sky. So 3 of our rulers, 3 of our peace signs, 3 of our rock and roll fingers, depending on where you're looking, will be between the sun and the moon. Now, like I said, this is not important now because we can use the sun to tell time. But what if? What if it was later, say now? Okay, the sun has set. We no longer have the sun in the sky. Can you use the moon to tell you what time it is? Now, I've kept the time visible right up here for you. It is 7:30, all right? And you can see there's the moon in the 4 p.m. position, and it's a crescent moon. And as we've learned, the crescent moon is 3 hours away. So if the crescent moon is lit on the right side, we know to look this direction for the sun, and we know to go 3 hours from the sun because it's crescent. 1, 2, 3 would be 7 p.m. So the sun must be in the 7 p.m. position because that's what the moon tells us. So when we go back up here to the clock, you can see absolutely. This bottom time here is the position of the sun. The top time is due daylight saving. So daylight saving is making it 8:30 for real on our clocks, but its position is 7:30. So and again, the 30 because we live in Tulsa. We talked about that last time. So we use the moon's phase to guide us to the sun, because remember, the sun is ultimately what's telling the time. Okay, let's do this again for, say, a waning crescent moon. Okay, so here's a waning crescent. It's in the 8 a.m. position. So what time is it? Well, it's 8 a.m. The moon is in the 8 a.m. position, and it's lit on the left, and we know it's a crescent, so we know we need to go 3 hours. 7, 6, 5. We look up here, 5:30. Perfect. That's exactly what we wanted to see. All right, let's try a quarter moon. Let's remind ourselves of our stats here. Quarter moons are 90 degrees away from the sun, which equates to 6 hours. So quarter moons are 6 hours apart. Do we see that here in our example? We absolutely do. Now you got to remember, you got to draw a line kind of from the, think about it from the North Pole, or it's Polaris down, if you will. But if you draw a line here, you'll notice the moon is in the 6 a.m. position. 1, 2, 3, 4, 5, 6 hours away from where the sun is. Perfect. That's exactly what we wanted to see. That's what we expect to see. The moon is orbited 90 degrees or 6 hours from the sun. So let's say we fast forward time a little bit. Say to here, could you prove that this is now a 9:30 sky? Well, sure you can. You see a quarter moon in the 3 p.m. position. 3 p.m., quarter moon means we need to go 6 hours, and it's lit on the right, so we're going to go that to the west here. So 1, 2, 3, 7, 8, 9. So we go to 4, 5, 6, 7, 8, 9, 9 p.m. That's what we see. The sun's in the 9 p.m. position. All right. So again, you're using the lunar phase to tell you which direction to look for the sun and how far away to put the sun. So now you're using the moon to tell time. All right, let's give you another example. This time the sun is not up at all. Here you go. Here's a 10 a.m. So we have the quarter moon in the 10 a.m. position, but it's lit on the left, so we have to go left. 9, 8, 7, 6, 5, 4. 6 hours because it's a quarter moon, and you can see it is 4:30. Okay. Now the whole time I've been giving you the time and everything. That's just because I want you to learn the concept, and really you're trying to prove that it is 4:30 or whatever time it is. Gibbous moons. Gibbous moons are probably the most complicated, just because they're the most uncommon, or I shouldn't say uncommon, most least popular, least known phase of moon. But they're 135 degrees or 9 hours from the sun. And so you can see here's a 9 a.m. gibbous moon and a 6 p.m. sun, though that is 9 hours apart. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's pretend a little bit later we go outside. Maybe we didn't see it here, but a couple hours later we go outside and we see this. So it's about a midnight-ish moon. All right, so the moon's right around noon, the 12 o'clock position. Well, if we know the gibbous moon is in the 12 o'clock position, then we know we need to go 9 hours, and you can see it is 9 p.m. So as I'm stressing here, it's all about using the moon's phase to find the sun, because it's ultimately the sun that tells the time. Full moons are the easiest ones ever, because they're opposite each other. So if the moon's at 6 a.m., the sun's at 6 p.m. when it's full. So if I move forward a few hours here, this is very simple. Here's a 1 p.m. moon, so you know the sun has to be at 1 a.m. 11 a.m. moon, 11 p.m. sun. Very simple, because full moons and the sun have to be opposite each other. So it makes it very easy to tell time with the full moon. So hopefully you get that concept. Now this definitely takes a lot of practice, because I've kind of reduced moon phases to just these 5. But you have to remember there are different degrees of crescent moons, different degrees of quarter moons, different degrees of gibbous moons, which is why I really wish phases were more of, here's a 0 hour move, 1 hour move, 1 hour moon, 2 hour moon, that kind of thing. We learned it by hour. Sort of size, rather than these names that we've come up with. But with that, let's just go to the evening sky. Let's go back to that evening sky that we saw earlier here. And this time, though, I've enlarged the moon so you can see it on the screen. Because tonight, this is Wednesday, if you're going out tonight on Wednesday, this is the quarter moon right there. And so you can see that it's 9 o'clock. Could you prove that it is 9 o'clock? All right, well, let me bring up my numbers again. Well, let's find out here. All right, so we see that the moon is in 2 p.m. position. Okay, 2 p.m. position. It's a quarter moon, so we need to move 6 hours forward. 3, 4, 5, 6, 7, 8. So this should be in the 8 o'clock position, right? Well, 9 o'clock is what our clock showed. This is now set for the clocks. So it shows 9 o'clock. It's 9, not 8 because of daylight savings. So you can see, you can use the moon to determine where the sun is located. So get out there the next couple nights. The moon's going to be up at a nice decent hour right when the sun sets. It'll be a quarter today. It'll be a gibbous in a few days. Use this new information and see if you can't prove that time on your watch or the time on your phone is actually the time using the moon. It's been a pleasure, guys. I will get you, I think, one last time next week when we talk about the Drake's equation. And talk a little bit about the aliens. But for now, have a good day.